To prepare the balance, set it on a vibration-free workplace. Set up the balance horizontally and level the balance by adjusting the balance feet. The air bubble should be in the center of the level. For precise measurements, the balance needs to be adjusted to laboratory conditions during initial setup and after a change of position or a large temperature change. We also recommend adjusting the balance every 4 weeks during operation. For adjustment, the balance is equipped with an internal calibration weight. See the manual for instructions. After adjusting the balance, turn it on and connect it to the computer. For setup, there are 2 choices. This is a diagram of a multi-balance mode setup. In other words, 1 balance per sensor unit. This is a diagram of a single balance mode setup. In other words, 1 balance for multiple sensor units. In this video, we'll show multi-balance mode. For single balance mode instructions, see the manual. Connect the magneto connecting cable to the balance and fix it on the magnet clamp. Place the free end of the cable and the plug on the balance. Push the tare button to zero out the scale. Put the sensor unit on the balance. Be sure to place it in the marked circle. Connect the sensor unit. To prevent noisy measurements, make sure both ends of the sensor unit cable don't touch each other. The cable from the balance to the magnetic clamp must lie freely as a loop without touching anything. Before weighing, wait at least 5 minutes to let the cable tension release. To make a Hyprop measurement, click the measurement wizard icon. Enter the following data, either via the wizard or directly in the manager. Measuring unit, name of the soil sample, sample ring type, sample ring weight. Remove the plastic cap from the sample and click Apply. Every Hyprop measurement runs in 4 phases, provided that tensio shafts and sensor units are properly degassed. Phase 1. In the regular measurement range, the tension value curve rises up without flattening until it reaches the boiling point of the water. Phase 2. In the boiling delay phase, when the system is filled and completely air-free, the tension value rises up to the boiling delay area, which is above the ambient air pressure. Phase 3. In the cavitation phase, water vapor is generated in the tensio shaft, and the tension value drops abruptly down to the boiling point. After this, the tension value decreases only slightly. Phase 4. In the air entry phase, the tension value again drops abruptly, now to 0, as air penetrates the ceramic. The air entry point is a material characteristic of the ceramic and amounts to about 8,800 hectopascals, or 880 kilopascals. This point can also be used for the evaluation. Note that often the optimal measuring curve up to the boiling delay cannot be achieved. If this happens, the curves then look similar to this example. But even these curves can be used for evaluation. Refer to the manual for exemplary measuring curves of various soils. You can finish a measurement in 3 ways. You can stop when the upper tensio shaft has reached the cavitation phase, or if you are planning to use the air entry point, then there are 2 possibilities. A. The air entry point of the first tensio shaft has been reached, and the second tensio shaft is still in the regular measurement range, phase 1, or in boiling delay, phase 2. In this case, the Hyprop can calculate the medial value of the tensio top and tensio bottom curve. Or B. When the air entry point of the first tensio shaft has been reached, and the second tensio shaft is still in the cavitation phase, phase 3, the medial value of the 2 can't yet be calculated. Then you must wait to stop until the air entry point of the second tensio shaft has been reached. After stopping, use the Hyprop Fit software to evaluate the measuring values. To do this, refer to the Hyprop Fit manual. After the measurement, the Hyprop needs the dry weight of the soil sample to calculate the volumetric water content based on the weight reduction. Put the soil sample in a drying pan. Open the clips of the sensor unit. Carefully remove the sample ring. Don't tilt it to avoid breaking the tensio shafts. If the soil sticks too tightly to the sensor unit, which is often the case with clayey soils, see the manual. Set the sample into the drying pan and clean the sample ring and silicone gasket above the pan to avoid losing sample. Dry the soil sample in a drying oven at 105 degrees Celsius for at least 24 hours. Weigh the sample and enter the net mass of the dry soil sample in the Hyprop Fit software using the register evaluation. The Hyprop is now ready to calculate the volumetric water content.